Phasor. Okay. Bismillahirrahmanirrahim. So today we're going to have chapter 6, which is coming from chapter 9 and 10 of your textbook, which is a phasor and steady state analysis. And if you look at the one I give you is actually the video I give you, all the links. Have you watched it or not? That one is the example of all this. So I give you first and then I give you this. Maybe you don't understand it. And then what is all about phasor? Phasor here consists of the sinusoidal or steady state analysis. We have phasor form, and remember last time we have capacitor and inductor. Both are working if you use AC, okay, AC form. And then we need to solve this thing in the AC form so that this one and this one will become like storage elements. Yeah, okay. And then there's some impedance and admittance and some phasor analysis. So everything that you apply in chapter 2, 3, 4, you will reapply it in the phasor analysis. Okay. And then for this part, like I said, if you have the voltage, this one, the DC voltage here, because this is under DC condition, the capacitor will act like what? Open circuit or a short circuit?
Open circuit.
Open circuit, right? So it will becomes like this, open circuit, and we cannot actually utilize full utilize this because current will be equal to 0. So this considered as problematic if you want to use it with respect to time like this. Okay, so because of that, we going to have this sinusoidal form. A sinusoidal is a signal that has the form of the sine or cosine function, right? So if it starts from 0 here, you know that it is a sine wave, right? A sine. So we usually write down the signal in terms of V1 with respect to t. So where is that t? This x-axis. We have the Wt here. So V1 with respect to time, and we have some amplitude which is Vm. That's why you have Vm here. Since this is a sine wave, then you write down sine, and then you have some angular frequency because of this sine wave have one cycle, right? A period of time from here up until here, or you can put it as a 2 pi. Or you just simply write down in terms of omega t. And you know that the omega is equal to 2 pi f, right? This one you learn it from your mathematics class, math class. So if you substitute, you know that a period here, what is a period? The starting point, if you start from 0, and it should end at 0. So you have 1 period, which is equal to 1 over frequency. Okay, and then if you substitute this into the equation, you will have 2 pi 1 over t here. And if you rearrange this equation, you have time, a period is equal to 2 pi over omega. Okay, so what if you have other signal which have some phase, something like V2 here, the V2, which has plus some phase, and the theta here is a phase. Okay, and if you have a plus sign of plus theta like this, then you should know that the signal should start from the left side of the graph here. This one plus, and if you have another signal, maybe V3, which has the sine and then omega t, maybe this is a minus some phase, then you should know that this one will have a will start from right side of the graph. So maybe here, start from here, okay, and then the theta 2 here is actually this theta 2 is actually here, okay, and you do not need to write down the positive or negative of the phase. You just know that it should start from where, on the right side or the left side. Okay, I think you have other methods to do this from your math class, but that's just for our, because we need to consider something like lagging or leading. And if you already watched the video, how we convert capacitor into Phasor form and how we make this inductor into the AC form, from time domain to frequency domain, then you should know that there's some leading and lagging of phase, right? So if capacitor, which one is leading? Current is leading or voltage is leading? For capacitor, anyone? Anyone watch that? Which one is leading? Current is leading or voltage is leading? Okay, you should watch that. Somebody just come in. For capacitor, current should be leading. For inductor, voltage should be leading. Voltage leading by 90 degree. For capacitor, current is leading by 90 degree. Then this voltage. Okay, so later I will explain more on that. Okay, only two sinusoidal value with the same frequency can be compared by their amplitude and phase difference. What does it mean by this? If you look at the previous, this one, you have this one, right? The VM, and then you have the sine wave, and then you have the angular frequency. Okay, so if you have two, let me change the color, maybe purple. Okay, let's see, maybe V1 signal and V3 signal. If you want to compare these two signals, you need to make sure that the omega, what is omega? Omega is the angular frequency. Angular frequency, and it is measured in radian per second. Okay, angular frequency are measured in radian per second. If you want to compare these V1 and V3 signals, you need to make sure that omega or the angular frequency are both same. Okay, and then the other thing that you need to consider is the whether this is a sine or a cosine. Both should be same so that you can compare what you want to compare. Maybe the amplitude or maybe the phase at the back of this. Okay, so these two. All right, so what you need to make sure same, the angular frequency and the sine or cosine. But usually if you want to solve a question, you use cosine. You always use cosine. And how to, if the question gives you something like Vm sine omega t, you need to convert it into cosine. How to do that? Go to this table. This is a cosine and this is a sine. And if you want to convert that, this is a negative sign and this is negative cosine. Then from sine to cosine, you should minus 90 degree. Okay, and from maybe from negative cosine to cosine, you plus with 180 degree. Coming from where? Because one quadrant here is equal to 90 degree. So you have 90 plus 90. That's why you have a plus 180 degree from negative cosine to cosine. Maybe later you will do understand this more. But if you want to use this example, if you have V1 which is equal to Vm sine omega t, then to convert this into cosine, then V1 will become a Vm cosine omega t. Because this is a sine, you need to minus 90 degree, right? This one. So you should minus with 90 degree. So now it is converted into cosine form. Is this clear? Or sleepy already?
Inshallah, can.
Okay. And then this part, if the phase difference is 0, like we had in our example, this one, right? Vm sine omega t without plus theta, there's nothing there. Then we say that the phase difference is actually equal to 0. There's nothing here. So if there are some phase difference, or maybe this is a plus theta or minus theta one, then we say that the phase difference is not 0, or it is out of phase. Later maybe we can see it clearly using graph. Right. If you have this question, which one is the amplitude? What is the amplitude for this signal?
5.
Come again?
5.
5? 5?
Yeah.
5, yes. The amplitude is 5. But always make a habit to convert this one into cosine form. So what is a cosine form? If you have this and you know that this is a sine, you want to convert it, you should minus with 90 degree. And this is a cosine. 5 cosine for 5 t, and then minus 60 degree. And what else? You need to minus with 90 degree, right? Then this one will become negative berapa? 130, right? Bukan. 40, 150. Sorry. And this is for 5t cosine 5. 5 cosine for 5t minus 150 degree. Betul kan? 6, 12, 15. Okay. So this is amplitude. And then what is phase? What is the phase? Phase is this one, right? So it is 150 degree. But if you didn't convert it into cosine, then you have this one, negative 60 degree. Okay, for phase. Okay. Next, what is the angular frequency? What is the angular frequency?
4 pi.
4, 5. And what is the unit?
Radian per second.
Yes, yeah, correct. And what is the t? You know that from the equation, we have 2 pi divided by omega, right? So 2 pi divided by 4 pi, then this one becomes 0.5 second. What about frequency? What is the frequency?
1/0.5.
Yeah, just reciprocal of this. So you have 2 hertz. Okay, is it clear? Clear, right? Kalau tak clear, you go back to math class. Okay, this one, the textbook, they didn't convert it into cosine. Tapi I want to get you used to cosine form. Okay, now this part, we have 2 signals, which is the I1 and I2. And like I said, if you want to compare 2 signals, like I1 and I2 like this, then you need to check whether your angular frequency, are they same? Are they same or not? Or not?
Same.
Same, right? This one, this and this, they are same. So you can compare. But you need to consider the other one, which is the sine and cosine. Are they same?
No.
No, right? So you need to change either one. Okay, let's say because I said that every time you want to solve the problem, you need to solve it in terms of cosine. And because of that, you want to change this one, convert it into cosine here. And since this is a negative sign here, so what should you do? A plus 90 degree or minus 90 degree?
Plus.
Plus. Okay, good. Plus 90 degree here. So if you want to convert that, then I1 will become negative. No more negative because now from negative sign becomes cosine. Then you should have a plus here. And this is 4 cosine. And this is 377t plus 25 and plus 90 degree. Okay. So this 2 will becomes a apa dia? It becomes a 115 degree, right? Okay. Now you can compare these two. But how to compare that? The best way is I think you need to just plot. Okay, plot. Let's say you have I1. I1 is equal to a plus 115, right? A plus 115. And from our theory, it says that if you want to have a plus this one, a plus 115, it should start from the left side, right? This one. Okay. So if you want to draw that, it will start from the left side because this is a plus, this is minus. So let me just draw a random one. And this is the 115 degree. Okay. And the other one, you have I2. Let me label first. This is I1. The blue color is I1. And the green color here is I2, which has negative 40 degree. And you know that negative should start from the right side. So you just draw this one and this one. The angle is actually 40 degree. Okay, is it clear? And from here, if you look at here, which one is actually leading? Is it I1 or I2?
I1.
I1. So we say that I1 leads I2 by how many degree? If you look from here up until here, 115 plus 40 equal to 100?
155.
55.
Yeah, very good. So by 155 degree. Okay, so this is the answer. Or you can also say I2 lags I1 by 155 degree, like this. Same. Okay. Which one you are not clear?
Madam, yang part graph tu we have to draw. Is it required?
It is not required, but for your own understanding, you can draw because you want to make sure that this and this should be plus, right? Or you can also use the quadrant value. This is maybe 40 degree, and then the other one is 115. 115 coming from here, and I'm not sure how you use this, but this is math. Then yeah, you should know how. So 115 plus 40, it is this is I1 and this is I2. So it is same, equal to 150 degree. Tapi how to do that? You need to check back your textbook. All right. Okay. before that, maybe I give you some more example. Keep. What if I have another one? I1 is equal to -4 sine berapa? I just give you the same example lah. -4 sine 377. And this one with 25 degree. This is T. Okay. Tapi it has another part which is plus 5 cosine plus 5 cosine 377T minus 40 degree. Sepanjang ni. Okay, what do you think? Can you see this? I know my handwriting macam apa je. Sebab my, what we call this, the digital pen is not really following my my handwriting. Okay, so what do you think here? Sekejap. Saya rasa kita belum masuk lagi in that Phasor form. So kita abaikan ni kejap. We going to enter this first and then we go back to that. Alright, Phasor can be in 3 forms. And what is a Phasor? Phasor is actually a complex number or complex form that represents the amplitude and also phase. Okay, as long you have these two things, you can actually solve most of the problem. Amplitude is VM or IM. It can be voltage signal or current signal. And what is phase? The theta, right? So you have that too. And what type of forms that you have in Phasor? There's 3 forms: rectangular, polar, and exponential. For rectangular, I think most of you, majority of you are familiar with rectangular because you have x-axis and y-axis like here, right? And then you want to find what is the x here. X is equal to R cosine, right? Cosine theta, betul tak? And y is R sine theta, correct? This one you learn it from your math class. And then what is the Z? Z is this this form, right? This apa panggil ni? Magnitude. Magnitude. So the Z is equal to x plus y, right? And you know that x is equal to r cosine theta. Then you just substitute r cosine theta. And plus r sine theta. That's why you have something like this. But you need to consider something else, which is the x-axis here is the real axis. And the y-axis here is the imaginary axis. If you have an imaginary axis, you should put j. Okay, and real axis is just a real number. So that's why for the y part here, you have j kat sini. Okay, so you should put j here and also j here. It is a imaginary. Usually maybe in your textbook you use I, but we want to differentiate between the j and the j here. It's supposed to be I, but we want to differentiate something from current. Because we usually use current and voltage, right? So we do not want to mix up with that current. But if you use calculator, your calculator will use I. I stand for current. No, I stand for imaginary. All right. This is clear? Is it clear? Saya harap korang tak tidur. Pertama yang duduk jauh-jauh ni.
Clear, madam.
Alhamdulillah. Okay. All right. Second, you have polar. Polar is like you have R. R is actually the amplitude. This is sebenarnya amplitude, tapi dia letak sebagai R. Okay, R. Tapi tak apa. Doesn't matter. It's just the way it represents. So this is a R, which is an amplitude. Sometimes we put it. Sometimes we put it as a VM and some theta, or IM some theta. Okay. And then the last part we have exponential. What is exponential? Usually you write down in terms of this VM E J theta. If this is a positive, then positive. If else, you have a negative. So sometimes we put it IM. I stand for the current, signal for the current. So it depends on what you have. Okay, something like this. But the thing that you need to know, if you convert it from DC to AC, or from time domain to frequency domain, you actually kenapa bodoh saya domain, you actually change from the time domain to frequency domain, right? From DC to AC. Berapa kali tulis? Okay, it becomes this is, if I put it in terms of signal for voltage, then we write it like this: V small letter with respect to time. But in AC form, it will becomes, or in phasor form, it becomes V bar, V capital letter. Why I put bar? Because of in your textbook, it didn't say V bar like this, but it bolds the capital letter. So V bold in your textbook. But since you cannot bold the thing, you only put a bar sign on the V here. Okay. Or sometimes you can also write down like V. The bar sign is down like this. So you can just use anything as long that you know that this is a phasor. Why you put bar? Because you want to differentiate between this V with respect to time or the phasor form. Because sometimes the small letter like this you can just write down in terms of like V only without the T. But you do understand this is with respect to time. Okay, because this is DC. Right. So if you want to solve the AC problem, it is better to put it in terms of phasor form. So it is easier to solve it. All right. Let's go back to this. Okay, the current. If you look at my writing here, I put a small letter, right? I small letter. And it is actually with respect to time. And this with time here. Okay. And we have all this. This is a very long equation. So how do you convert it into phasor form? How do you convert it into phasor form? If I put it one by one, okay. Let's say I put 1 is a -4 sine 377t plus 25 degree, and you want to put it in polar form. Polar form. And polar form is you need to have the magnitude and also the phase, right? This thing. So which one you need to put? And you know that this part needs to convert it into cosine form, right? So the previous one you had is this one plus 4 cosine 115. 4 cosine 377t plus 115 degree, because you already simplified into cosine form because you want to solve both, right? So it's supposed to be both in cosine. Okay, this is not done yet because it is still in this time domain. You want it to be in this domain, phasor domain or frequency domain. Then what is that? Polar form. Anyone? 4.
And then the symbol 115.
Yes. Yeah, correct. Like this. Okay, the next one. Despite what is on the right side here? Okay, what is on the right side?
5. -40.
Yeah. Okay, very good. But if you look at here, this is a very long equation, right? Okay. Since we have this, we can actually solve this. Tapi there's some rules. Before we enter all these yellow rules here, you look at here, there's something we call it as a Euler identity, which is this. I think you guys are familiar with. If you have a complex form, or what we say this, exponential form, we can actually have a x-axis and y-axis, right? And some plus minus, but plus minus depends on, if you consider plus, then this one will become plus. If minus here, then minus down here. Okay, the equation will becomes like what you want, this one. Okay, and then you know that this x is actually the real part, right? Real, and the y is a imaginary part. And you know that from our this complex form, you can actually derive the cosine and sine. Okay, why cosine and sine only? Because the amplitude is basically becomes 1. Why 1? Because in front of this exponential, we have 1 here. Okay, so that's why you have only cosine and sine. Okay, I'm actually want to have this complex conjugate. Okay, the normal form is this form, right? X plus jy. You have real axis and imaginary axis. Okay, but if you want to have it in complex conjugate, you need to have asterisk. So the way you write in terms of rectangular form, this is rectangular. This one becomes complex conjugate, and then equal to, you just change the positive and negative of this. If this is a positive, then complex conjugate of z here will become x minus jy, right? And then you know that in terms of polar form, it will becomes like r theta. Okay, and in terms of exponential form, it will becomes r e j theta. But if you want to write that down in complex conjugate form, you need to write down with some asterisk, and then just change the positive or negative of this phase. So since this is a positive, then you just write down r with a negative theta. What about this one? You just change the positive or negative of the theta here. Okay, so this one will become z asterisk this one, and then become r e minus j theta, like this. Okay, this is how you write down in terms of complex conjugate. Is it clear? I know this lecture will be very quick, tapi tak apa, you just check back with the slide, no need to worry because everything here. Okay, now if you look at here, we have addition and subtraction, and if you look at this and this, they are in what we call this, rectangular form, right? This is addition because we have plus, and this is minus, subtraction. If you want to do this addition and subtraction, it should better to solve it in terms of rectangular form. Because why? The real axis you can add together, and the imaginary axis you can add together for addition, if this is plus. And if this is a minus, the real axis you can minus together, and imaginary you can just minus together. Clear, right? Okay. Then multiplication and division. These two, if you look at here, it's better to solve this in terms of polar form. Okay, since this is a multiplication, Z1 into Z2, then the amplitude should be multiplied together, but the phase here, you should plus together. For division, for the Z1 divide by Z2, then the amplitude of 1 should be divided by this amplitude of 2, and the phase should be minus together. Okay, so this is second. So you can actually check on their the way how they solve it. This is using rectangular, the first two, and the other two using polar form. For reciprocal or square root, you have 1 divided by z because this is reciprocal like this. Okay. Yeah, you can write down in terms of this or 1 over z like this. And then this is the amplitude part, you can reciprocal the amplitude part. That's why you have r like this, and then the phase you should have a conjugate of that, or the other of theta. So since this is a plus, then this is what a minus. And then for the square root is actually like this, right? And then if you want to write down in terms of this square root, then this one, the amplitude should be square root 2 and divide by theta divide by 2. If you have square root, bukan square root. If you have like this or something like this, then the answer will be r, then this part theta divide by 3. Depends on what you have. This one complex conjugate already clear. Euler's identity also clear, right? I think the trickiest part is number 5 and 6. But for all this, use only when you don't have when you cannot use calculator. Okay, so that's why it is important to watch the video on how to use calculator for the complex form. First you need to specify complex form first, and then you just enter the value lah. But please check on the video because I will not explain it here, but I want you to calculate using calculator. Can you? This into this. What is it equal to? Can somebody give me the answer without using the red and the yellow rules just now? You just use calculator. What do you get? This plus this, 4 of 115 phase angle plus 5 with negative 40 degree angle. What do you get? How to do that? First you need to set the mode to complex, right? And then you enter 4 with some angle 115. Did you watch it or not? And then you get some answer. You press plus, and then you have a 5 with negative 40 degree. For negative 40 degree, you need to use something like this. In your calculator, please write down in terms of like this. 5 in a bracket, negative 40 degree. something like this. Because I'm afraid you might have some mistake at negative 40 degree there. So better not to do that silly mistake. You just use bracket into a bracket and then find the answer. And the one you have is the first answer they will give you is a rectangular form. You need to change it into polar form. Usually the answer will be in polar form. So do you get this answer? This is what I had in my calculator. 100? No. Okay, this one. Right. Do you get this?
I get until the rectangular form one only.
Okay. What do you get for let me change the color. Okay. I think better you put it like this. Usually for this side, I will do like 4 and then I put 115 degree and then I will put equal sign. So that the answer for the equal sign, I will reuse. It will become, this is an answer, right? Plus with this one. Answer plus this part. And then I will get this answer. Sekejap. Ya, saya try lagi sekali. Can I get the same thing? You guys should, all of you should try because I'm going to give you the attendance. And the attendance is a pop quiz of something similar of this. Okay. Kalau tak boleh lepas yang ni and then you cannot find leads or lagging. Okay. Dapat tak? Maybe some of you get this answer code to in rectangular form. Do you get the in rectangular form?
Yes, I get in rectangular form.
This one code 9 and you write down in terms of rectangular form, right? Do you get this?
Yes.
Okay,
I
that's
get it.
okay. Now, change it into polar form. If you have the old calculator, then you press Shift plus. If you have in the new calculator, then you use. Sebab saya tak ada the new calculator, I cannot tell you. But you need to check on, is it 3 or something? Change the mode and then select the polar form. Or it will directly give answer. Saya pun tak ingat dah. Okay. Dapat tak? Dapat? Or which one you are not clear? Or maybe I ask you one by one ke macam mana? Yes. Yes, Tasha. You want to ask something?
Tak.
Oh, you
Hold
want to okay. Do I have the calculator here? Sekejap. I download the calculator, but I need to renew the version. I want to activate my license. I don't want to activate because this actually free for education. Else you need to pay. Cashew 57 download. $570, right? Okay, managed to do or not?
I
Calculator.
still cannot convert into apa polar form.
Polar form. Okay.
Only anti-rectangular form je.
Are you using the old calculator or the new one?
The new one 570.
Sekejap.
Kasih.
Okay, kejap. Let me check the here. Still have time. Where is it? Video kan? Okay, kita tengok kat video sebab I don't have the calculator. Kalau saya boleh download dia punya, because
Bismillahirrahmanirrahim.
the last one.
Assalamualaikum warahmatullahi wabarakatuh. How to use a calculator? If you look at the
Check this one. Okay, if you look at here, biar saya cepatkan sikit. Here. Dia ada ni kan? Complex form. First, you need to set the complex form on mode, and then complex. Ni yang mana ni? Saya pun dah pening. Oh, that one. Tapi I think the video, because I actually tindih dua video, then it becomes like lagging sikit. This part, I make it as an answer and then bahagi, divide by 8 plus 2i. And then I get the answer for this 1.882. Okay. Because you want to see the last answer ni Okay, jap. 7.882 plus this one. Okay. This. Yang ni, this one that you need to change. You choose 3. Tapi nak choose tu, kejap. Dekat mana? Biar saya ada suara sikit.
two is a complex form. Two.
Oh, sekejap. 2. Normal.
And then you can choose number complex form.
Oh, 2.
Okay,
So
two.
you need
And
to
then you
choose 2
can
here.
choose number 3.
Here, this is a complex, right? You shift, I think you should press shift and then complex. Complex is number 2. So you can view this answer in complex form. See, 72 with some angular frequency of that. Okay, shift and 2. So So Tasha, do you get the answer?
Yes, yes.
Yes, yeah. Because I forgot the what we want to press. Shift 2. Okay. Nice. All right, done. Do you get the last answer, everyone? Okay ke tak? Saya takutlah korang tak faham. I'm afraid that you might lose some information here and there because I'm going to give you the soalan pop quiz. Can I? Okay, let's test you. Maybe some of you not getting it in the class, but maybe you will do understand it in the question. Kau sama je. Sekejap. Where is the question? Okay, this one. Okay. I give you in the chat box. Right. Please try. The question is almost similar of what we are having in the class. Okay, this is a question. This one you need to upload. The first one, upload. But you need to find what is in V, Phasor form, and what is I, Phasor form. Right? And then you need to evaluate whether which one is lagging and which one is leading. This one you just type the answer. Remember to change the sign to cosine first. If you can do this, I think your final will be good, inshallah. Else you need to work on it. Okay, siapa ni? Abdul Hassan. Okay. Abdullah Hassan, are you in Saudi? The car condition.
Yes, madam.
Oh, okay. But you listen to my lecture, right?
Yeah, I just arrived my home.
Oh, okay then.
Sorry, madam.
Okay, maybe I just paste the link so that you guys can try if you don't have time here. Oh, is dah masuk ke? Skandar? Are you here?
Yes, madam. Why?
There, okay, because I just read your message in Telegram.
Oh, sorry.
Okay then. Okay, good. Yes.